it doesn't just need to be a common denominator. It needs to be a more specific. Feel free to read ahead. Lowest common denominator, least common denominator, however you want to say it. Least common denominator in order to add or subtract rational expressions, aka fractions. Okay. Following steps can be used to find the LCD of rational expressions. This is the hardest part. It's so easy to find a common denominator when you're in 5th grade. You just multiply the numbers. You're done. Blah. But that's not what you want to do now. That'll get you a common denominator, but won't give you a least common denominator. And then you'll have this terrible factoring problem that you'll have to do. So we're trying to avoid that by using the least common denominator. Following steps can be used to find the least common denominator of a rational expression. First thing we want to do is factor all the denominators. If they are factorable, factor all the denominators. We want to be able to see what they are made out of. Like, what are their little parts, their little binomials. Okay. And then for your least common denominator, in that least common denominator, you're going to put all the different factors that appear for each denominator. So like if you see a factor, it needs to go on your common denominator. If you see a factor, it needs to go on your common denominator. If you have any repeating factors, so like if you have an x minus 2 and an x minus 2, that would be an x minus 2 squared. So any repeating factors, you'll write those with exponents. There it is. If a factor is common for any of the denominators, meaning if it shows up in more than one denominator, you only have to list that factor to the highest degree that it appears, which is like the highest exponent that it appears. Highest exponent that it appears. So what that means, like, say we have like one fraction that has an x minus 3 and the other fraction has a 5x plus 1 and also an x minus 3. If this x minus 3 is in both, you don't need to write it in your common denominator twice. You only need to write it once with the highest exponent that it has. We haven't even tried one yet. You can't say what yet. Take that back. Okay, look at what we got. Those denominators, do they factor? No, they're both linear. They don't even have a GCF. Okay, so thinking about my least common denominator, I'm going to come over here and build it out.
They both have an X.
That doesn't matter. Okay, so our least common denominator needs to have every factor that shows up in a denominator. But if a factor shows up in both, you don't have to write it twice. So my least common denominator needs a 2x minus 1, and it needs an x plus 3, because each of those factors appear in a denominator. So, going back to our fraction, the first denominator already has a 2x minus 1, so what else would it need? An x plus 3. Which means what do I need to do to the numerator? Times it by x plus 3, right? Remember when you're finding common denominators, anything you do to the bottom of a fraction, you've got to do to the top of the fraction. My second fraction already had an x plus 3, so what does it need? A 2x minus 1. Along with its numerator, we'll need to multiply it by 2x minus 1. All right. For the numerators, we do want to simplify the numerators a little bit, but you don't have to FOIL out your LCD unless you just really enjoy foiling. But for my new numerator on the first fraction, it's going to be a 5x plus 15. And then my denominator now should match the LCD, which is 2x minus 1, x plus 3. Again, you don't have to FOIL out your denominator unless you really want to. And then we got a minus sign. And then what is our new numerator on the right fraction?
2x squared minus x.
Very good, robots. 2x squared minus x. When I write my LCD, does it matter what order I write these two factors in? No. Multiplication is commutative. You can write it any order you want to. Okay, now that we have a common denominator, throwing it back to grade 5, which part do you actually subtract? The numerator. It is right. Yes, it is right from the left also. Yes. Just the numerators. What happens to the denominators? They stay the same. So I know my denominator is going to stay exactly what it is now, but we will need to subtract those two numerators. Be careful when you subtract the numerators though, because I need to do this whole numerator minus this whole numerator, which means this negative is going to affect both of those. It's kind of like distributing it. So we're going to have a 5x plus 15 minus a 2x squared and minus a negative x, which would turn into a plus x. When we write our answer, which term do we want to write first? The 2x squared, but what does it need to be? It'll be a negative 2x squared, yep. And then we'll have a 5x minus a negative x, which is a positive 6x. Good job. And then 15 has no other like term, so just bring down your plus 15. And then you're going to leave the denominator the same. And that's it. And then again, you do have that stipulation. If you want to write the stipulation and say, as long as x is not negative 3, as long as x is not 1/2, because that would make our denominator 0. But honestly, we'll get more in that tomorrow whenever we start solving equations. And when you solve, it's really important to not get an answer that would make a denominator 0. That wasn't too bad, was it? Did your LCD information make more sense? You just need, yeah, any factor that appears, it needs to be in your LCD. If it appears twice on each, like one on each, you don't have to write it twice. All right, next one. Again, I'm going to build my LCD. I got an 8 over 9x squared plus 2x over 3x squared plus 3x. Building out my least common denominator. Okay, we got a 9x squared. This one right here, this 3x squared plus 3x, does actually factor. What factors?
3x
Yeah.
plus 1.
Very good. You can, it has a GCF of 3x, so 3x times x plus 1. Okay, and I'm going to cross that out so we don't even see it anymore. Okay, so my LCD is definitely going to have numbers, it's going to have some variables, and it's going to have a parenthesis. Because in my LCD, I need to write every factor that appears in a denominator. If it appears on both denominators, you only have to write it once with the highest exponent that it appears with. Okay. Let's start with the number. For some reason, the number, all of a sudden we forget how to just find a common denominator with numbers. You see how both of these have numbers in the denominator? One has a 9, one has a 3. I kind of just think about that, throwing it back to like 5th grade. 1/9 plus 1/3. If you had to add those, what would be the LCD of these two numbers? Like, what would be your common denominator?
4 9.
Well, don't actually add them. Just tell me what is the denominator.
1 3 plus
It would be a 9. Good job, Liz. We know 5th grade math. It would be a 9 for your common denominator.
Oh.
That was embarrassing, guys. Okay. Sorry, Mr. Wallace. They really do know how to add fractions, I promise you. Yeah. Okay, so if I have a 9 and a 3, okay, my LCD number is going to be the 9. Okay, because that would be your least common denominator with a 9 and a 3. And then look, I got an x squared on this one and an x. Technically, that is a factor that shows up in both. So in my LCD, we want to write it with the highest exponent that it appears. So if I have an x squared and I have an x, what is the highest exponent that it appears with? It's an x squared. Okay, and then I have one more factor that shows up. What is that one more factor? X plus 1. That also needs to go on my LCD because we need every factor that shows up in a denominator. So I have my LCD so I can build out my common denominators now. The first fraction already has a 9x squared, so what does it need?
X plus 1.
He's gone. We can go back to being dumb, guys. Yes. X plus 1. Which means the numerator also needs a times x plus 1. Okay, this one is a 3x and x plus 1, so if we're trying to get it to match the least common denominator, what does it still need? It doesn't need a 9x squared. It needs
3x.
a 3x. It has a 3x already, so it would still need another 3x to match that LCD. Okay, and then I'm going to clean up those numerators. For the denominator, we can just write it as the LCD now. My new numerator on the first fraction, what is it now?
8x plus 8.
8x plus 8, good. My denominator is now just a 9x squared times x plus 1. You don't have to distribute that out unless you just really enjoy distributing. And then we'll get a plus sign. Okay, and then my new numerator on the second one, 6x squared. 2x times 3x would be 6x squared. Okay. And again, we'll keep that denominator the same. It should be the LCD now, 9x squared times x plus 1. All right, and again, remember when you add fractions, which part are you adding? The numerator. What happens to the denominator?
It stays
It stays the same. Very good. So we're just adding these numerators together. Are there any like terms? Any like terms in those numerators that we can put together? No. So we'll just kind of write it as one polynomial in the numerator. Writing which term first? 6x squared. And we'll have a positive 8x and a positive 8 over our LCD of 9x squared times x plus 1. Whew. Looks good. Yeah. Again, what would be the stipulation? What is the denominator? What are these x's in the denominator not allowed to be?
0.
0. And what's the other one?
9. Negative 9.
No, not negative 9. Negative 1, right, because if we put a negative 1 right here, then this whole factor would turn into a 0, and if the whole factor turns into a 0, then you'd have a 0 in your denominator, and it would explode. Alright, that was the hardest one. If you mastered that one, that was the hardest one. They get easier from there. Alright, we got a 5 over x squared plus 2x minus 3. And we're going to add 3 over 2x squared plus x minus 15. What am I going to start by doing?
Least common denominator.
By doing what? Factoring. We got to factor those two denominators to see what they're made out of. I'm going to use a Post-it for that so it doesn't get messy. First one is...
3x minus 1.
Okay, alright. Two numbers that multiply to negative 3 but add to 2. Nicholas said they were? Positive 3 and negative 1. Excellent. Good. Okay. I'm literally going to cross out the old denominator and then write my new factors, x plus 3, x minus 1. Okay, the second denominator, that is not an easy factoring.
It's 2 times negative 15.
Slow down. Okay, we're going to need two numbers that multiply to a times c, which would be negative 30.
Negative 6 and 5. Negative 6 and 5.
Negative 6 or positive 6?
Positive 6, negative 5. Let's come on.
Come on, Liz. Yes, positive 6, negative 5, because they have to be able to add to that 1. Alright, do those go in my parentheses?
No.
No. Those are just what you split your middle term with.
That looks about right.
Then what?
You factor it out.
You have a common
2x for the first one.
2x for the first one. What is that called, Alicia? Common...
Factoring.
Greatest common factor. There it is.
That's how the other one has to be negative 5.
Excellent. Okay. So I'm going to cross out my old denominator. I'm going to write what my new factors are. I got an x plus 3. I got a 2x minus 5. Okay. Now we can at least see what they're made out of, because that's going to help me build out my least common denominator.
Ooh, there's going to be an x plus 3 squared.
Is there? Let's think about it. So in my least common denominator, I need to write every factor that appears in a denominator. If it appears in both denominators, do I have to write it twice? No. If you write it twice, you're actually not using a least common denominator. You're using just a common denominator. So looking at the first one, I know my LCD needs an x plus 3 because that shows up. I need an x minus 1 because that shows up in a denominator. And now looking at the second one, again, do I have to write x plus 3 again? No. We already have an x plus 3 in our LCD. So we just need that 2x minus 5.
Oh.
Yeah, this one's definitely easier than the last one. Okay, so now that I know what my least common denominator is, I'm going to go back to my two initial fractions. This first fraction has an x plus 3 and x minus 1, so what does it still need? A 2x minus 5. Which means our numerator will need to also multiply by 2x minus 5. It needs an x minus 1, right? It has the x plus 3, it has the 2x minus 5, it still needs that x minus 1, which means the numerator also needs an x minus 1. Alright, let's simplify our numerators. Our denominators we can just leave in factored form, we don't have to FOIL those out. Although it's a pain in the butt to write all of them. X minus 1. Okay, new numerator. If I distribute my numerator, I'm going to get 10x minus 25. Very good. And then we'll have a plus sign. My denominator is now matching the LCD. Again, is the order that we write all these factors in important? No. Multiplication you can write in whichever order you want. What is its new numerator?
3x minus 3.
3x minus 3. Good job. I almost wrote a 5. Minus. Okay. We have a least common denominator now, which means we need to add those two together. Let's go ahead and do that using talking to our partners if we need help.
It would be 13 minus 1.
Don't tell the answer out loud. Compare your answer with your neighbors. Make sure we both got the same thing.
What are you doing something?
Yeah.
Like the whole time?
Say it again.
My, okay, we but we like to play all the Fortnite games. So we like do but
How many numbers would the denominator not be allowed to
you
equal?
have to share with
A lot.
More specific.
like
I just said how many numbers?
Three.
Three
Negative 2.5.
numbers.
I mean,
We're going to add those two
2.5.
numerators.
And then 1.
Yeah. Alright. If I combine like terms on my two numerators. So what's my first term going to be? 13x. Okay. Christina, my second term, what's it going to be? Excellent job. Walking around, I saw a lot of right answers. Denominator again stays the same.
that's so that's right.
Okay, let's think about all the denominators not allowed to be numbers. There's 3 of them.
5.
There's X.
Not 5.
Negative
2.5.
Negative
positive
Negative 3 because of this factor.
2.5.
2.5.
2.5 because of this factor.
Positive 1.
Positive 1 because of this factor. Very good.
Good job, everybody.
I know, teamwork. Alright, what's different about this one? There's 3. Does that make it harder? There's adding and subtracting. Good. No, it does not necessarily make it harder. Nicholas. Thank you. What do we want to start by doing?
X plus 5, X minus 5.
What are you doing when you're saying that? Factoring. Right. One of these denominators doesn't factor. Which one?
X minus 5.
The x minus 5, right. The other two do factor. The first one Nick said was,
X plus 5, X minus 5.
right, do you remember the name of that?
Factor. Oh, difference of squares.
Difference of squares. Alright, the third one.
Third one. It would be X and then X plus 5.
Very good. The third one only has a GCF. Okay. It's good to have it factored because now I can build that least common denominator. Alright, remember in our least common denominator we want to put every factor that appears anywhere in a denominator. If it appears in both denominators, you only have to write it once with the highest exponent that you ever see it with.
Would we include X in that?
That's a great question. So I know I need an x plus 5. I know I need an x minus 5 because my first denominator. My second denominator has an x minus 5. Do I write it twice?
No.
No, we already have an x minus 5. My third denominator has an x plus 5 and it has an x. Should we include that? Yeah. Any factor that appears. Okay, so that's going to help me figure out what I need to multiply by on each one. My first denominator, what does it still need? An x. So I need to multiply the top by x. My second denominator needs an x and what else?
X plus 5.
An x plus 5. An x times an x plus 5. And then my last denominator
Just needs an X minus 5.
just needs an x minus 5. Right.
But we have to do that over the next one.
Alright. And then simplifying my numerators, what's my first new and improved numerator? X squared over 4x times x plus 5 times x minus 5. This one actually wouldn't be too hard to FOIL out the denominator, but you don't have to. Second one. 4x squared plus 20x. Good job, Dana. Because 4x times x would be 4x squared. 4x times 5 would be 20x. And then denominator is just going to stay the same.
Minus 3x plus 15.
Minus, and then we'll have 3x minus 15.
Plus.
It'll turn into a plus 15, but not yet.
Oh.
Because right now we're just doing the 3 distributed. Okay. So when we go to add and subtract all of our numerators, Nick reminded us that because we have this minus right here, that minus is going to need to be distributed to both of these. So that 3 would become a negative 3x. The negative 15 would become a positive 15. Which term are we going to start combining? The squared term, the non-squared term, or the constant? The squared term, right. So going all across those numerators, what are my squared terms going to combine to? 5x squared. Good. Okay, and then my non-squared variable, 17, because I have 20 minus 3 of them, plus 17x. And then lastly, plus 15, because negative times negative 15, plus 15. There's going to be 3 numbers that our denominator is not supposed to equal. What are they? Negative 5 and 5. And one more?
0.
And 0, right. Because if you put a 0 here, the whole denominator would turn into 0. You ready for the fun ones?
Yeah.
You want to take a peek on the back already?
Flip it right back.
Alright, we did a few that had complex fractions the other day, but the complex fractions that we had previously didn't have any adding or subtracting in the complex fraction. Now we do have adding or subtracting. Okay, do y'all see where the big division bar is on both of these?
Oh, yeah.
Yep.
Alright, here's my big division bar. Right here. On the second one, I have a big division bar right here. Alright, there's kind of 2 ways you could do this. First way, we could, we could actually do the subtraction on the top, and then once we have it, it's just one fraction, we could divide it by this bottom fraction. The other way, technically what you could do is if you multiply every part of this fraction by the least common denominator, it should simplify it. So that means you'd have to multiply this by the least common denominator, you'd have to multiply the 5 by the least common denominator, you have to multiply this fraction by the least common denominator. I'm going to show us that way. It's easy. We just learned how to find least common denominator. Before I write my least common denominator, though, I do want to rewrite this denominator because that one factors.
Yep, that would be negative 4 and 3.
Yep, negative 4, positive 3. Good. All right. Multiply everything by the least common denominator. Basically, it's like, kind of like, you know how whenever you have an equation, so say you have an equation, it's like 1/2 x minus 3 equals 5/4 x plus 7. What you start by doing is you'd multiply the whole thing by the least common denominator of these, and that gets rid of the fraction. That's kind of the idea that we're going behind. Tobachi, can you lift your head, hon? Multiply everything by the LCD. By the LCD. So that means I need to actually figure out what my LCD is. LCD. Alright, let's look at all those denominators. I got this as a denominator. The 5 doesn't have a denominator, and then these 2 are denominators. So what would be my least common denominator?
X minus 4x.
X minus 4x plus 3. Very good. X minus 4x plus 3. That's my LCD.
So that would be
Hold on, Nicholas. You're always like 5 steps ahead of me.
Oh,
Okay, so this whole entire ugly looking fraction, we're going to multiply by the LCD, which is x minus 4, x plus 3.
nice.
x minus 4x plus 3.
You said it's easier way?
No, there's a harder way. This is the easier way, yeah. So I need to take this LCD and I need to multiply it to this fraction. I need to multiply it to this number. I need to multiply it to this fraction. So I'm going to literally write out all of those multiplies. So I'm going to take my LCD, which again is x plus 4, x, what is it, minus 4x plus 3? Yeah, my sign's confused. X minus 4x plus 3. And I'm going to multiply it to this first fraction, times 3 over x minus 4. Okay. And then we're going to do that same LCD again, and this time we're going to multiply it to this 5. So we have a negative 5, and then we're going to multiply our LCD, x minus 4, x plus 3. So we distributed it to the first fraction, we distributed it to the 5, and then we have this big giant denominator here, and we're going to multiply it to my fraction that's on the bottom as well. So again, I'm going to take that LCD, which is x minus 4, x plus 3, and we're going to multiply it to the fraction that's on the bottom, which is 2x over x minus 4, x plus 3. All right, catch up. Any question?
No, I'm just stretching.
Got it, okay. Okay, so it's not overwhelming. I'm going to cover up different parts of it so we can just focus in on one little part at a time. I'm going to cover up this whole ugly denominator. I'm going to cover up the minus 5 times x minus 4 times x plus 3. So we can just focus in on this one right here. We learned how to do this yesterday. When you're multiplying, can you cancel diagonally?
Oh, cross out x minus 4.
Yes, you're going to cross out your x minus 4s. That's gone, that's gone. So we really just need to do 3 times x plus 3, which is 3x plus 9. Okay. Hold on, Nicholas. Hold on. Okay. And then I have this negative 5 here that I have to multiply by. We know what this is when it's not factored. Remember, it was x squared minus x, what is that, minus 12? Let's cross it out. So we have this minus 5 that we'll need to distribute into this to simplify it. So negative 5 times x squared would be negative 5x squared. Negative 5 times negative x would be plus 5x. And then negative 5 times negative 12 would be plus 60. All right, that's both of my numerators. I simplified them. Okay, now I'm going to cover up both numerators. We're going to focus just on the denominator, which would do the thing we did yesterday. And what would happen?
You cancel out x minus 1 and x plus 3.
Cancel, cancel. Which would leave us with just 2x over 1, which is just 2x. So on my denominator here, I'm going to put 2x. You could combine like terms on the top, but that's about it. Okay. Combining like terms on my numerator, I'll have a negative 5x squared at the beginning. A plus 8x, very good. Plus a 9 and a 60 over 2x. And we're done. As long as x is not 0. Right, because if x was 0, the denominator would be 0. Okay. And the reason this one seemed complicated is because I actually showed this work here. You're going to get good enough to where you're going to literally write your LCD over here, and you're going to be able to see that x minus 4 canceling and just immediately go from here to here. Like, you're going to look at that and just be like, oh, x minus 4 cancels. It's just 3 times x plus 3. This one I might have to write because that one I did have to actually see the distributing. I bet some people could do that in your heads. Same thing down here. Like, you're going to be able to see, oh, it's just x minus 4x plus 3 times this. Those are going to cancel. I'll have a 2x. I promise you, like, the hardest part of this is the fact that we showed our work. Isn't that sad? Okay. Similar on this one. We should be able to multiply everything by the LCD, but I need to figure out what my LCD is first. Do any of these denominators factor? I'm going to highlight all the denominators. We got a 5, we got a 3, we got a 15, and we got a 5x minus 5, which does factor. What does that factor into?
5x minus 1.
That factors just ever so slightly. I thought I'd waited long enough for it to dry. I did not. Okay. All right, building my LCD. Calculus math. Oh, magnetors. I forgot about them. Okay, remember when you have LCDs, or whenever you have denominators that are numbers, think about them as like just fractions like you did when you were in first grade. Right? Kindergarten, when you all do fractions. So like this one has a denominator of 5, so it would be like 1/5. This would be like 1/3 because there's a denominator of 3. This would be like 1/15. This would be like 1/5. So you look at all these numbers, what would be the LCD of all of those? 15, right, because it's the smallest number that they all divide into evenly. So 15 is going to be in my LCD. And just one tiny other little thing. What else is in my LCD? X minus 1. We don't need the 5 because the 5 already goes into 15.
Oh, yeah.
Okay, so we should ideally be able to multiply this whole entire thing by the LCD to get it to simplify. Again, the hardest part about this is the fact that I'm going to show my work. So we got to multiply everything by 15 times x minus 1, which means we got to distribute to both fractions on the top, both fractions on the bottom. All right, so the first one's going to say 15 x minus 1, that's my LCD, times the first fraction, which is x over 5. Okay, and then again we'll have that 15 times x minus 1. Actually, I might write the fraction first. It really doesn't matter. But so then I have a minus x over 3 times my LCD, 15 times x minus 1. Okay, so there we distribute it to everything on the top. Okay, and then giant fraction bar. And then we're going to distribute it to everything on the bottom. So we'll have 15 x minus 1 times x over 15 plus, same thing, LCD times x over 5 times x minus 1. Ooh, okay. Again, to not get overwhelmed, I literally cover up part of it. So I'm not looking at it going like, oh, I don't know. Okay, so I'm going to hide part of the numerator. I'm going to hide the whole denominator for now. I don't want to even think about it. And we're just focusing in on that 15x minus 1 times x.
The 15 can simplify to 2.
The 15 and the 5 can simplify, because both of those you can divide by 5. And then we just have 3 times x minus 1 times x. So we would have 3 times x minus 1 times x.
3x squared minus 3x.
That should be 3x times x minus 1, which is 3x squared minus 3x. Good job. Okay, so when I'm going to write my answer should have 3x squared minus 3x. Sure. I love the size of your sweater, or your shirt, Isha. It fits you so well. The oversized look is in. Okay, that was our first fraction, or we're going to move to our second fraction that's also on the numerator. All right. Looking diagonally, can we cancel anything? Wow, this is way bigger than your last one. Yeah. You know how many people came to the last tour to my room? 1. That was it. A group of 1. Were you with that group? It was very weird. Okay, look diagonally. Can we cancel anything?
Yeah, 15 and 3 become 5 and 1.
Very good. The 15 and 3 are becoming 5 and 1. Parents, do you guys have any questions? This is algebra 2. Yeah. No? Just enjoying life? Are we your first choice? We're not. We're not. Okay. That's worse. You excited? You want to come here? Yeah. I'm talking to you. Yeah. You want to come here? No? I guess. Okay. All right. We're no one's first choice. All right. We'll take. That's fine. That's fine. That's fine. We're okay. All right. Just writing out what we have. We have negative x over. Actually, that's a 1 now. Times 5 times x minus 1 over 1.
So 5x minus 5.
Minus 5x.
So we have a minus 5x times x minus 1, which would be
Minus 5x squared plus
Yep.
5x.
minus 5x squared plus 5x. So that's also on my big giant numerator. Minus 5x squared plus 5x. minus 5x squared plus 5x. Okay. Looking at our big giant denominator now. Again, just one part at a time. Don't overwhelm yourself. Where's my...
15's cancel.
Hold on. I'm not there, Nicholas. I'm not there. You're welcome. Make us your first choice. Okay. Yes, Nick. 15's cancel. Good job. Anything else? No, we'll just distribute to get x squared minus x. And then looking at my second fraction. Yay, lots of canceling. The x minus 1s. And the 5 and 15 would turn into a 1 and a 3. Plus 3x. Okay. Both, there's like terms on both the numerator and denominator that could combine. 3x squared minus 5x squared. Minus 2x squared. Okay. And then we have negative 3x plus 5x, which is plus 2x. And on the bottom we'll have x squared plus 2x, because the negative x plus 2. Does this one feel like it could simplify more?
Yeah.
Yes. So the reason it does actually simplify a little bit more. The reason it does is because each of the numerator terms and the denominator terms have a GCF. What's the GCF on the top? X. Actually, yeah, 2x. And if I take out a 2x, what's left?
Negative x plus 1.
Actually, let's take out a negative 2x. Negative 2x.
Negative x plus 1.
Negative x minus.
I'm going to do x minus 1. Because I took out a negative 2x. I switched it up on you. Okay. What would be the GCF on the bottom? X. And that'll be leaving me with x plus 2. Now do y'all see what cancels? The x, right. So this one did have like one tiny other term that would simplify a little bit more. Leaving me with... Very good. Okay. As long as x is not negative 2. Good. Practice SAT question is easier than either of the ones we just did. It's either the ones on the front. Those SAT writers, look at them giving you a break. You're like, you've been dealing with this, Brody, way too long. Let's make it easy. All right, practice SAT question. Let's see, we got 2x plus 6 over x plus 2 squared minus 2 over x plus 2. The expression above is equivalent to a over x plus 2 squared. This right here is just a stipulation. It says a is a positive constant. X can't equal negative 2, obviously, because you'd have a 0 on your denominator. The question says, what is the value of a? What is it asking us to do? That is not what it's asking us to do. What is it asking us to do? Daniel Shelton! No sleeping in here. What is it asking us to do?
It's asking us to find the value of a.
More specific. How do we find the value of a?
We probably start by factoring.
Oh.
We don't need a fact. None of those factors.
We have to subtract.
You just have to. They're asking us to subtract these. Yeah.
Yeah, 2x plus 6 minus.
They're basically. They're giving you a hint. Step 1. They're telling you what the LCD is already. They're telling you it's x plus 2 squared.
But.
Yeah. So does this denominator need to change?
No.
Does this one need anything? What does this one need?
X plus 1.
It needs an x plus 2. So this one needs an x plus 2. It's okay. Guys, I thought this was the easier question.
Oh, no, I was thinking we could use the x to cancel some
I
of
was
the one on the
thinking
left side.
just put a square up in there.
Okay.
Then you have to actually.
Alright, so on the denominators, now they're both x plus 2 squareds. What is my new and improved numerator?
2x plus 4.
2x plus 4. Okay. So now we can do the actual subtraction on the top because we do have that common denominator.
Which would be 2 over.
Yep. The 2x minus 2x, those would cancel. 6 minus the 4 would become 2 over x plus 2 squared. So to answer their question, what's the value of a?
2.
A is 2.
Oh, we subtract.
Alright. You got 7 minutes to cram. When there's 41 minutes left on the clock, I'm going to have you clear off your desk because we're starting when there's 40 minutes left on the clock. So you got 7 minutes to cram or 7 minutes. to meditate. You can do that later if you need to. You'll probably finish early. Nope, it's on paper. Because I caught too many people